Okay, a standard four-part panel discussion. I'm Julian Coy. I run the Code Collective group, which is a group that's upskilling Baltimore's high-tech talent. And we've been operating for just over a year now. I've got a couple new organizers. We've been doing Tech Tuesday, of which Chad is a regular attendee. Yeah, I feel like I'm in good company with the climate tech people. I'll tell you what, climate capitalism was not on my 25 bingo card. But I met up with the climate tech community for the first time through Equitech. That was in May. That's when I met, when I met Kavi, and maybe Dietrich as well, at that or another event. We have the privilege of sharing a time with Scott Christensen, who's like the biggest name in all of ecosystem development as it relates to environment, it's a blessing and a curse.
Everyone knows him.
Yeah, he keeps a spreadsheet. So that's my introduction. Well, firstly, we're going to pass around the products. So this is the first product for the camera. Y'all have seen it already. Has everybody seen this? Did you see it? Okay. Everybody knows what this is. It's storage charge in the elastic bands, and Sammy will talk about that later. The second product is
It's dry.
It's dry. Okay. Dietrich assures me there's nothing toxic about this. This is a water flow meter and may do some other things. This is the
Water quality sensor.
Water quality sensor, thank you. Has anybody not seen the water quality sensor? You haven't seen it? Pretty nice model. And finally, the Pirl EV charger. This is a charger for electric vehicles. We'll get into this. Have you seen this already? For this panel, I required physical products because there's a thing out there called vaporware. So by requiring physical products has kind of been a filter of things that are imagined or things that are intended and things that are here and now. So this is the most interactive panel in all of the Greater Baltimore Climate Summit. And that's
I'm sorry.
that's why they put us in the room without the projector.
That's what I know. That's cool. But I haven't seen this one. So I'm excited about this one.
All right.
The primary innovation is that current EV chargers are rip and replace. So if you have a commercial EV charger installation, you usually replace it every 3 to 4 years because of wear and tear. And what they do is they go in there, take out the whole thing and throw it away. Nothing is recycled. It's very expensive. And so we're designing something that is incredibly climate friendly. And I think it's gradually going to become a new way of building hardware, which is field upgradability. We call this base the anchor. So this is what manages the cables. This goes into your EV car, and this goes into your power source. And so this is the anchor. So for field upgradability to work, you really need, things to be kind of very simple and small. So there's been a lot of work on thermal management, but primarily say this is installed, right? And you need to upgrade it or replace it. All you have to do, open the slot that I just did. You pull down this lever and this comes out. And so our business now becomes, shipping you new versions. When you send it back to us, there's actually a lot of, modular designs of the charging circuits where we can even remove certain components so that we're not throwing all of this away. This you can do without a certified electrician. So the owner can self-perform the maintenance, which there's a very, very big electrician shortage right now. But even more importantly, even if we had an abundance of labor, it's really more for the sake of uptime. So if this is down, within 3 minutes, you can do the hot swap and you're back online so that your customers who are relying on you always have electricity for their vehicles. So that's really what we're doing.
Can you tell us a little bit about your company, Pirl? I've read it's inspired by the pearl that the oysters produce, and you also have some experience in Africa?
Yeah, I started my career building power plants, mostly in Africa. I was working for a U.S. company. At that time, they owned the most number of privately owned power plants in Africa. And it's a company based in Arlington. It was a really fun job. I really loved it. I'm from Ghana originally, so it's really passionate about kind of putting more electrons on the grid. At that time, Sub-Saharan Africa generated about the same amount of electricity as New York City, which is, considering that there's 1 billion people on the continent, is very power starved. So I did that for a while. The company sold my group to a private equity investor, and I wanted to do something else because I was very passionate about building power plants, but the mission had changed. And so that's when I left and over time found a group of engineers, and gradually we got Pirl off the ground.
All right. And you also have a powerful USB charger, I believe.
Yeah, so I'll start with kind of the backstory. When we started the company around 2015, 2016, and at that time, it was just very clear that the future was going to be driven by the drop in cost of batteries and the increase in energy density of batteries. So there's something called the gravimetric, which measures weight, weight/power per gram of lithium-ion batteries. And you could just see that the future is just going to be, we're going to have batteries everywhere. So we started off building a home portable battery system, and we tried to raise money for that. And the investors were like, you haven't done anything yet. We don't know this team, so go build something, sell it, and come back to us. So we had developed this charging circuit because the battery had USB circuits. So we extracted the USB circuit into a separate product, launched it, and we sold 2,400 units to 1,700 customers in 15 countries of just that charging circuit. So that was sort of the first product that we had, ideated, developed, built, shipped, and delivered to customers. It's been operating for about 7 years now. I still use mine every day. Our customers have been using it. And I think that was really a bonding moment for what we really stand for, which is building charging circuits or charging products that really last a long time. So our goal is that our EV charger is going to last about 10 years versus kind of 3 to 4 years for commercial EV charging systems. And that's just kind of our commitment as a company.
What does resilience mean to you?
I think I just spoke to it. Resilience is simply longevity. So the systems we built are used currently and are going to be used by customers every day. And they rely on them for very important tasks. So our USB product, obviously for consumer electronics, and the EV, obviously for powering people's electric vehicles, but they're using it every day. And so resilience means longevity. If the product is out there and it's being used by users and it can last for a decade, you reduce incidence of e-waste, right? You obviously reduce headaches for customers because they're not having to swap out these systems. And then I think most importantly, resilience really for us means peace of mind for the customer and also peace of mind for us. So our first product, for example, we had some returns, and even managing the process of handling returns was very, very painful and took up a lot of management time. And so for us, resilience also means peace of mind for the customer, but also peace of mind for us. And so we use premium components and we design things. A lot of our work is managing excess thermal management. Thermal management is what causes these electronics components to fail. So we need to do a really good job so that when our products, let's say this charger is placed in direct sunlight, right, and there's a heat wave and it's charging a car at max, it can do that and keep doing that for 5-10 years. That is what resilience really means for us. Is on the engineering side, it means really, really effective thermal management, but on the customer side, it means peace of mind for a really long time, which also means peace of mind for us.
Awesome. And I did a little bit of reading into commercial systems that are already out there for charging. There are evidently 3 levels. Level 1, which is just on the realm of 1,000 watts, I think. Level 2, about 2,000. Level 3, which is 4,000 or so. And they all work on different voltages. So level 1, you can just plug into your wall at your home. Level 2, you need 240. Level 3, you need 480. There's also a couple different connectors out there. The Tesla connector is becoming popular, so says the internet.
Yeah.
And there's also a more traditional connector. Can you speak to how the Pirl sits within the realm of existing standards?
Yeah, this is level 1 and level 2 capable. I use it every day for my EV. And in terms of the cable systems, it's compatible with all the cable systems out there. So the Tesla cable, technically the NACS, the NACS, and then the other cable is J1772. This is easily compatible, and like I showed, if you need to swap a cable, again, very easy. These are lever connectors, and you just swap them out. So maybe I'll start with this. So you just open up the anchor, and then this is, if you need to swap any cable to a different standard, these are lever terminals. So all you have to do is this, and then you pull the cable out. It's very, very simple, very modular, and which gives you flexibility as a customer.
Awesome. So it's an adapter of sorts as well.
In a way.
Cool. Anything more you'd like to say about your company before we move on to another one?
No, that's it.
All right. Thank you, Kavi.
Yeah, thanks.
That's awesome. I have no idea this entire thing. So
Yeah.
We'll do the water quality assessor next. Where is it? Did everybody get to see the water quality monitor?
Yeah.
All right.
Know about it?
Tell us all about it.
For posterity.
My name is Dietrich. I live out in Germantown, Maryland. And one of the things that we started off a few years ago is saying, how do communities participate in environmental science? And yeah, you can stand by a creek and you can count bugs. This is a valid method to assess whether a creek is healthy or not. You can totally do that, and it's done today with kids and adults. You can also take samples from the water and send them to the lab. That's also okay. If you want to pay somewhere between $25 and $50 a shot, you can do that. Or you can take little sticks and various other tests that are incredibly expensive. Or, on the first thing, you actually pay for a water quality monitor $15,000 worth of hardware. And that is fine if you're a professional organization, if you're a consultancy company, if you're the government. These are the things that you need to do, and these are the things that are appropriate. But what if you're just kayaking and want to know what the water is like? What if you want to make sure that the local construction zone doesn't contaminate your creek with sand or sediment, or if you have an algae bloom coming in, or if you're worried about that groundwater is getting pushed to the saltwater, which is a huge problem, by the way, in coastal areas, where the water table drops down and you have saltwater intrusion. So these are all everyday problems that speak to the water quality, and there's really nothing out there that's easy to use. A friend of mine said, "Can you build one?" I said, "Sure." I don't know. He said, "Can you build one for $500? And I said, "I guess. I don't know. How hard can it be?" Well, it is quite hard. And so with that crazy idea, I went to Cyrus out here, and Cyrus and his engineering company built with us the first working prototype. That was, it worked. It had issues, but I think this is the cool part about this, is that I knew Cyrus from before, and I knew that in order to convince anybody that this is a viable thing, we need to have something that sort of works in my hands. It doesn't have to be perfect, can be ugly, it isn't, but it could have been. And that gets you the chips to get to the next level. And the chips was grant funding, so we raised some money from the Department of Education that says, hey, this would be really cool for kids, students in classroom, to do hands-on, place-based STEM education. And so we raised quite a bit of funding on this one. We made this one out of it. This is our latest model. This is now injection moldable, so we can stamp these out by the tens of thousands. By the way, we can do all of that in Maryland. So this was one of the requirements, and I really credit the Department of Education, or SBR in general. They focus on U.S. manufacturing. And so they put a lot of legal language behind it, but there is a really good reason behind it, and that's your IP doesn't leak abroad. No, nothing we do is made in China. So the shells are made here, the electronics is made in Germantown, everything is assembled here. And does that raise your costs? To some extent it does, not as much as you'd think. Right? With the transfer of knowledge abroad, basically the loss of the company in 2 years where your IP is stolen, it doesn't raise the overall cost all that much. So we pulled this together. So we now have these water quality monitors that are in STEM education use. They measure things like how much salt's in the water, how much sand's in the water, chlorophyll in the water, water temperature, all this stuff. And in parallel to this sensor, we built an app, and we built an entire web portal with a SaaS model on the back end, where we're basically saying, okay, so these are education components that ride together with this. So if you have a 5th grade kids that want to know all our macroinvertebrates, and it's all cool by the creek, we have a program for this. Last week I spent with 120 7th and 8th graders. We had a programming for this one, had about stream health, construction zones, and riparian buffer zones, and all of that stuff. So this sensor is a component in an ecosystem that has to do with community outreach and education. And so our next step now is raise money like everybody else, and go and see and generate demand or generate sales for this one. We're ready to mass produce. We're really excited about it. And I think also Maryland's a really good place for it, because Maryland is very coastal. It's got a lot of interesting waterways. It's got a lot of connection with the water. It's got a lot of industry around the water. The oystermen, the fishermen, the entire area is very focused on that. And there's a lot of innovation. A lot of the technology in this thing comes from medical device and DoD. So all my colleagues are either medical device or DoDs. We built this to very high specifications because it needs to survive 5th graders. That's a challenge. I know, right? So we had one of these things come back, the other model, and it rattled. And the teacher sent it back and was really apologetic. I said, what happened? And I said, my kids threw rocks at it. I said, so they set it up somewhere as target practice. And they threw rocks at it. And I was like, okay. So
It's a good stress test.
It still worked. It was still waterproof, but so we opened it up. We figured out that the battery holder had come unloose. Yeah. So we looked at it. We redesigned the battery holder. Wow. Right, and now all the devices have now a battery holder. So the battery had come loose and choked around in it, and the battery holder now survives fifth graders. I can drop this in here, and basically floats by design because fifth graders will lose it. It falls overboard and it's gone. People ask me, well, how does it work? So it works in a couple of ways. You can sink this down in the water. This is clay, by the way. This is not toxic. We use this in school demos all the time. This is actually just clay. So now it sends the data to my app. And the idea is that in the app, the students connect that with their STEM education. They learn about clay, they learn about oysters, and oysters need a little bit of turbidity, and they need a certain temperature profile, whereas other fish like trout or so don't. And so you have experimental place-based learning in line with the entire educational context that the teachers need to teach. Yeah, and it floats because otherwise you lose it. And we don't want to do this, so we could have made it heavier. And you tie weights to it, and you tie basically a rock to it. So I did a thing and I found a lava rock, tied it to it, and then towed it behind me in a kayak. And that was good fun. Nice. So we can do with this. So there's a whole bunch of experiments you can do with this device, but it's also good for citizen science and education. Tomorrow we're pitching a really big project in Orlando. Where we're saying we're doing a 90-day, that's the pitch, we're doing a 90-day pilot with the city of Orlando and various stakeholders to do a community-based water quality monitoring of stormwater and floodwater drains. So that would be dozens of units and many organizations working with us together. That's the pitch tomorrow. So it's not just for schools.
No, that's awesome. I do have a note from Code Collective. So injection molding.
Yeah.
What is it?
Injection molding is basically you take two forms out of either aluminum or steel that are negatives. You inject hot plastic into it. Sometimes you spin the entire thing.
Could be metal too, right?
You can do it in metal, but it's difficult to do in metal if you have a radio on the inside. So we need to be plastic. This one is yellow, by the way. If you go to my website, you see them green, and that's because we use recycled plastic. This one is yellow for marketing reasons, but the products themselves are green because we only use recycled nylon for this one. But yeah, injection molding is the next step for us, and would be done here in Maryland, and it would be way cheaper to manufacture.
This one here, was it injection molded?
This one is MJF, Multi-Jet Fusion in Atlanta. So it's basically 3D printing for adults.
Okay.
So if you think about it, it's a powder and you run the laser over it and it melts into place. And it's about as flexible as 3D printing. It's as fast. So I can order something. If you say, okay, I'm a customer, I want this thing in purple and I want it to say purple on it. Yeah, okay, give me 2 days and I'll have it for you. Right, that's the advantage. You can't do that with injection molding. You can do that, but it is a lot more expensive than injection molding.
Interesting. But I guess good for quick turnarounds.
Really good for quick turnarounds and very stable, very robust, very chemically resistant. It's amazing. The thing is bomb-proof. So,
and a lot of engineering went into this all around, right? So you had somebody had to model the outside, I guess, similar to Kavi's unit.
Yeah.
Similar to all your units.
So, by the way, it's draining for a reason. It's okay, it's water. These wings here, still not waterproof. They're supposed to fill with water. And that decreases the overall buoyancy, but allows me to put a line on it, on the sides. There was no other hook for a line, and if we made these things not waterproof, or made these things airproof, then the buoyancy would be too much. So yeah, there's a lot of experiments behind this.
The Goldilocks buoyancy.
The Goldilocks buoyancy. And on the sensor side, this one is cool. We have a pH, which looks exactly the same, dissolved oxygen, nitrate, phosphate as well. So different sensors for these things as well.
So for someone looking to manufacture in Maryland, can you maybe go a little bit deep dive on all the considerations, all the options you looked at, best practices for manufacturing locally?
Yeah. Number one, talk to Cyrus. Number two, talk to Cyrus again. Because if he doesn't know how to do it, he knows somebody who knows how to do it. So but now we've gone through this. Then don't be afraid of hobbyist technology. And I'm saying this deliberately because these things are not run on an Arduino. They're not, but they're run on something that's sort of similar to the architecture of an Arduino, and an Arduino is, I don't know, $10, right? The modern day stuff you can get from the hobbyist technology is plenty good for very advanced applications. So don't fall into the trap saying, oh yeah, I have a thing that works in my basement and I use an Arduino, but then the next scale up is I need to hire a gigantic industrial company and design my own chips and design everything from scratch. You don't have to do that. Full disclosure, the circuits boards are made in Maryland in the basement of somebody right here. So, they are 3D printing CNC, all of these things are desktop now, easy to use and scalable because we can stamp these things out by the hundreds.
How are they doing the PCBs?
So the PCBs are bought in from California, but the population is done in the basement.
Oh, the pick and places.
The pick and places.
Yeah, the pick and place.
You can get a $3,000 pick and place now.
Yeah.
3,000. You don't have to, and it works. It works great on a multi-layered board. It's perfectly fine.
How did you come to this conclusion? Where did you start from when you were thinking about manufacturing, and how did you end up, knowing all these sort of ways of putting together and finding someone with a pick and place in their basement? What was your journey?
I like talking to people, and I don't know anything about electronics, so people tell me a thing, and I like to have one-on-one conversations. So everybody I deal with has to be in Maryland or in Virginia or somewhere, liking on the phone saying, how do you do this? How's this work? Is this cool? Is this a good idea? Is this a terrible idea? If this is a terrible idea, then we're not doing it. Right? Now, if you have a contractor in China and you give them a terrible idea, they will execute the terrible idea because that's what they get paid for. And then you end up with 500 shells or 500 things that don't fit. They're too spec, but they don't work. Here, I can go to Cyrus saying, do you think this is a good idea? And he says, I get lost. This is terrible. Don't do this. I know what I'm saying. But this has happened. And where you come up with an idea and you guys are experts in what you do. I'm not. I'm a biologist, right? I see what it does, but I don't know how it needs to be done. And so when I come up with an idea, I need to have somebody give me very quick feedback saying, without NDA, without hocus pocus, like if I needed a big power analysis, I would call you saying, what do you think of this idea? And then you say, well, maybe or maybe not. And that interaction has to be local. And Maryland's really cool because it is local. You have Hopkins, University of Maryland, you have big medtech where we are, you have amazing engineers, amazing electronics, really good software people. Everybody is here and they're super friendly and one of ecosystem. That's really where we started.
Awesome. Let's get to Mr. Samuel's product. Honestly, this is my favorite product.
Mine too.
I first saw this at the Chesapeake Bay Seed Fund Green Entrepreneurs Roundtable, administered by Mr. Scott Christensen, who's in the other room. This is just a model. Samuel, he wanted me to make it abundantly clear. This is a model for a 500 kilogram unit that is so well protected that if the band snaps, you're not going to get cut in half or worse. Has anybody not seen the model yet?
I have
seen it. The camera. You can imagine how this thing gets wound up a little bit.
I love this. I saw it once at Salisbury, and it was like, oh, that is
We pitched there.
And what I saw is when your booth says power over it or something, and then this thing, I was like, oh, this is genius. This is so cool.
And Samuel is evidently a local. I think you're a student or
I'm a student at UMBC.
UMBC?
Yes.
Okay, that's my alma mater.
Oh, that's great.
Computer engineering class of 2016.
Well, mechanical engineering.
All right, adjacent fields. Yeah, tell us about what brought you here, what you hope to do with the battery. Tell us about the big one.
Yeah, I can. First of all, it's great to share a panel with you guys. I'm so impressed with the technology you guys are developing. So with our battery, as the renewable energy increases to be the main use of energy, we know that the wind is not always blowing and the sun is not always shining. So you need batteries, but current batteries, they're very bad for the environment. They cost a lot, and they only last an average of 6 years. So we came up with the idea of using, instead of lithium, Trisa. This elastic band, that's what is green, because it's actually made out of Trisa. And the concept is very simple. We have a motor that elongates the band, and when you need the energy, the band comes back and moves a generator and produce electricity. It's like the old grandma clock that you wind up with your hand, but just take that and make a battery an industrial case. This is the mock-up, the one that you were referring. It's a 7-foot tall battery, 80 centimeters wide, and that one in the lab has a maximum capacity of 5 kilowatt hour. That's like 4 hours to energy of an average household house. We plan that
that's 4 times the daily energy of the average house.
No, it's 4 hours for an average house. Yeah. So what you will do with this technology is like you put the solar panels in your house. You have energy in the day. And in the night, in the last 4 to 8 hours that you don't use the energy, the battery is gonna get you to those hours.
Taking the function of a Tesla Powerwall.
Exactly. Yeah. that's what we want to do.
Cool. And the chief advantages of this product over that, and I'd also like to do some comparisons with water-based potential energy systems, which are good on a grand scale.
Yeah, of course.
The comparisons, as I see it, is the weight is definitely higher.
Yeah.
The energy density, you might say, is lower, but the advantages are we don't have to go get lithium from China or from Indian grave sites. We can just grow it. The energy literally grows on trees.
That's a good slogan. I'm going to copy that. I'm going to put it there. Exactly that. The 500 kilogram battery, it's actually a little bit less.
It's about a watt hour per gram, you might estimate.
Yeah, but the one that we currently have, it weighs a lot because we have a lot of sensors there and a lot of mechanical systems that are not actually supposed just to sensor. And we also put a giant casing, way more than it would actually be the one that you need, and that casing makes it a lot more heavy. But it is a little bit dense. It weighs more than lithium-ion batteries, but lasts around 20 years. A lithium-ion battery lasts on average 6. I mean, our phones, every 3 to 4 years, the battery is dead. So in our technology, lasts 20 years.
Each band lasts many years?
Each band lasts 5 years, and you will replace it as if you were replacing the ink of the printer.
Okay, but for every 5 years?
Yeah.
I would have thought 1 year. No, this is extremely, and this is awesome.
Appreciate it.
How did you come to finding out that tree sap has the elasticity and longevity and all the appropriate characteristics for this?
Yeah, of course. I had the privilege to work in a soccer ball factory when I was 15 years old, and soccer balls in the inside actually are made out of natural rubber that is a type of tree sap. Yeah, exactly. And my job was just looking how the ball bounce.
Great job.
I mean, I was
job with
like,
this.
yeah, exactly. So I'm testing it, and one day I said, "What do we use this soccer ball to make a battery?" I told my supervisor, and he said, "No, no." I said, "Okay, I'm gonna do it. Just gonna do it." And that was the initial deal. Yeah.
Can you talk a little bit about the supply of the tree sap to make the bands? What types of trees are we talking about? What sort of volumes are we talking about? I don't think you plan to sort of cut down on the entire Amazon rainforest, but my sense is there's probably some large volumes here. So I'm curious how you're thinking about all the way from the trees directly to the band.
Of course. So, let's talk about the process, how you extract the tree sap. I don't know if you guys know maple syrup, the process that you do with maple syrup. We don't need to cut the tree. We don't need to kill it. So just make a small tap and the tree sap start getting out. Actually how he said, the energy goes out of the tree without hurting them. And there is a whole industry related to that. Tires are made of this material. They use natural tree sap with a type of fossil fuel. That's what tires are black. We only use the part that is tree sap, so that's why it elongates more than a tire. And actually, you don't need that much. The 7-foot battery is only 20 kilograms of rubber, so that's I don't know how to make that comparison, but imagine a weight in the gym, that amount of rubber is the one they use. So around 4 trees producing 1 year, it's one battery for 5 kilowatt hours. So imagine every battery that we sell, there are going to be 4 trees planted producing for 30 years tree sap. So as you said, we don't need to extract, we just need to plant. So that's the concept.
And you're going to do the planting on the trees, or are you going to just work with other organizations?
Well, I do have a small tree sap in my backyard, but I'm not
for that.
No, we're actually working with the company that I was working when I was 15 years old. I'm actually working with that right now, and they're the ones that provided the natural tree sap because they already have the contacts and have the whole system there. So we're working with they are the ones that work with the farmers, and we just get it. But it's a tree sap that it even grows in the United States. I'm from Colombia, so it grows a lot in Colombia, but it doesn't need a specific environment. It's a very worldwide.
That's cool.
But I'd like to invite Mr. Cyrus up to ask a question about your experiences and lessons that you've learned.
Thank you, Julian. All right, so first and foremost, I don't know everything, so please don't come ask me questions. If I know something, I'll help. So I've got a question for each one of you. Give in summary the one thing that you would tell another company, another individual, another entrepreneur who is starting a company and developing hardware. What advice would you give them?
Something that you start realizing while you're pitching, while you're selling, or you're raising funds, because we're going to be raising funds and we're going to build that, and also selling the product, is that you're not selling a company. In the grand scheme, you're selling a company, but the thing that's going to convince the people is not the company, it's not relative to the product, it's the story behind it. So my advice will sell a good story, because stories are the ones that connect and move people. And they will remember you by this story.
Yeah, that's great.
How about you, Kobe?
So the one thing I would advise is take time to create magic. And by that, I mean, take the time to build something that is really special, that when people interact with it, it sort of gives them a totally different experience. There's going to be a lot of temptation to cut corners. When we started, we used to hear all the time, why don't you just buy these cheap components from China and just slap it together? Why don't you just buy an off-the-shelf version of this product and put your logo on it, right? And there are all these sort of like shortcuts, with the benefit of hindsight, those would have been disastrous. You would have built something and then you wouldn't have sold anything after. Or even if you're able to sell something after, especially in my industry, things like fires become really catastrophic. Right. So I would advise anyone that, take the narrow path and take your time, and it's going to cost twice as much and take 3 times as long, more. But that magic you create can last for 10, 20 years that any other path you just would not have. Like, you're going to be 80 and look back and be proud that you build that thing, even though it took 5 years versus 1 year for the shortcut. So it really pays off to take the time to create magic.
I like that. Dietrich.
I have two. One of them is when you start a hardware project, even when you work for a big company, you have to ask yourself, why doesn't it exist yet? And the answer is never that you were the first one with the idea. That's arrogance. You're not. Somebody else had the idea probably 10 years before you. Somebody smarter than you will ever be. So the question is, why is it not on the market? And there are 2 reasons. One, it isn't possible. Or it isn't possible with technology as it was then. Or the other one is somebody did put it on the market, but put it into the wrong market, right? So there's a whole bunch of this in biotech specifically. There's a whole raft of companies with a really amazing tech that went after, for example, anthrax detection. And so you need to target your market with the right technology. That's number one. The other one is a much more practical. When you start out a company, surround yourself with the smartest people you can find. Buy them beers or coffee and talk to them. Don't go into non-disclosure agreements informal and pretend you're pregnant. Find people you can trust, you can have a dinner with, you can have a talk with, and just listen to them, right? I mean, this area is amazingly rich in extraordinarily smart people, and just have a coffee, go to people, talk to them. That's all.
I like that. So to recap, make sure you've got a good story. Don't just make another Me Too product. Actually build something that means something that is different, something that is unique. Make magic. Talk to the experts. Surround yourself with the experts. And you said before, find out why. Because you know what? In the end, the smartest products, the coolest products out there won't sell if it's not solving a problem. Awesome, guys. Great panel.
I've got a couple words to close this out. Firstly, this is the Code Collective Products of Resilience panel at the Greater Baltimore Climate Summit. I maintain the largest calendar of community tech events in all of Baltimore. That's at codecollective.us. And there's one last thing that was on the agenda. It's where we all say, here's to a bright green future in unison. All right? 3, 2, 1. Here's to a bright future. Thank you all.
Julian, nicely done. That was awesome. Thank you. Good to see you guys. Good to see you.
Thank you for attending.